days, oh, not 2 days, 5 or 6 days after taking a quiz that was not a very successful quiz for most people. Um, which I, again, have said how hard circles are. So I would say it's not a surprise, but the problem is we took an entire day to work on some of the problems for this quiz. I created a one-page sheet and we did it and we seemed to be getting it. And then I feel like, and maybe I'm wrong, but I feel like we didn't look at it again before the quiz and we forgot everything we did in class. I've told you guys this before. If you're listening to this, you cannot just put this stuff away and expect to remember it. You've got to look this stuff over again the night before a quiz and not just glance at it. Like you need to try to do every single problem that we did in class on your own. That's the only way you're going to be successful in this class. So if you're watching this, it's a good sign that you care. Just remember that moving forward. Remember it when you're coming in to do the retake. Don't just watch the video whenever you watch it, unless it's the night before, I guess. Go back and review this stuff the day before, the night before you come in to take a retake or an original quiz also. All right, with that in mind, here we go. So this is the sheet I was talking about. We did this in class. I don't know what day. It obviously depends on which class I have you, which period. But I told you in class, I said these three problems. This problem here. Oh, did not mean to do that. Why did it do that? Let's try that again. That should highlight. There we go. That problem, and that problem. I said that is on your quiz coming up. On your quiz Monday. Make sure you look at them again Sunday night, because a lot of you got it in class and it was a little more difficult probably on the quiz. Again, I never just put the exact same thing on a quiz, trying to test your knowledge and your understanding, not just seeing if you can memorize stuff and plug numbers in. You got to look this stuff over. So I'm going to go into another. Oh, this one also came up in a way. That one right there. It wasn't, I mean, it was on the quiz in one particular problem. It was part of another problem, but we're still making a huge mistake that I'm going to go over. I already went over it in one review video. I'm going to go back over it again in this video. But let me go to the other presentation or the other slide, I guess. All right, so here we go. I'm going to start with this one up here. Here's the number one thing. And again, it's not just when a figure is complex, but that seems to make more people do what I'm about to show you. If I have an angle here, so actually, I'm just going to write. It's probably not going to be perfect, but we'll do that. So if I have an angle here, and this angle is 20 degrees, actually, let's make it realistic. Angle is 40 degrees. 40-degree angle. I'm talking about this angle right here. I've still had a lot of people on the quiz saying, oh, well, then that means this 80 degree is 80 degrees. This arc right here is 80 degrees. Because I just multiply that angle by 2. No, no, no. Now, I went over this in class after the quiz, so maybe everybody hopefully gets it now. But just to make sure, you can't just take any angle that's inside the circle and multiply it times 2. There is only one, well, technically 2 situations when you can take an angle and multiply it by 2 and get the arc. That's when the angle is on, or the vertex really is on the circle. So this was one of the questions that was on the quiz. It was a separate question, but it had something just like this section, like let's do this. It had something like this section of this particular diagram, and that's all it had. It didn't have all the stuff on the left. And you had to figure out what the arc was. There was a little bit of a twist, though, because I didn't just ask you for this arc here. I asked you for a different arc. So you had to solve for this arc first, which again is just 2 times the angle. So then you had to use that information and solve for a different arc. And a lot of people didn't catch that. A lot of people did. But the only time an arc is twice the angle is when the vertex of the angle is on the circle right there. So this vertex, this vertex, this vertex, and this vertex, all of those angles, and we're going to go over this in a minute, all of those angles would be 1/2 the arc, or the arc would be twice the angles. But not this middle angle here, not in here, none of those angles, not the 40 degrees. And just think about it. I went over this in class. How could it be true? And just erase all of it and zoom in. How could it be true that this is 40 degrees here, which would mean this is 40 degrees because that's vertical angles. That would mean if I just multiplied those angles by 2 to get the arc, we're saying this would be 80 and also this one would be 80. They're not even close to the same size. So again, that doesn't even make sense if you just look at the arcs in the picture. It was a little tougher to tell in the picture on the quiz that the arcs were different sizes, but not that much more difficult. So you cannot just multiply an angle inside a circle times 2. You can only do that, again, when the vertex is on the circle. That's when you multiply the angle by 2, or you can divide the arc by 2 if you're trying to get the angle. Again, go back and review. This is just a quick review video. That was one thing. Let's see. We'll come back to that. So I already talked about this situation over here. That angle is half of its arc, which is this arc here. Or you could say the arc is twice the angle. Talked about inscribed angles. All right, so now we can go ahead and solve this one out over here. Oh, let me zoom out. That's probably good. Yeah. All right. So now I'm going to do a bunch of stuff in this one picture here to cover a few different things. If we have two lines that cross, so I'm talking about these two right here. First of all, a lot of people thought they were congruent because in the picture they look pretty similar, but you can't say they're congruent unless you can prove that. Clearly, these are not congruent. So just because two lines cross in a circle does not mean they're congruent. You'd have to be given some information, which there was no information at all. There was no information on the first problem, at least, about angles. You could not say the two line segments were equal. I can move a line segment back and forth, so that's another reason they can't be equal. I could move this segment here back and forth, which would change everything. So I can't say that anything is equal when I'd be able to move that line segment back and forth, because that would change things. It would make the arcs different. I wouldn't have angles there, I guess. But anyway, you cannot say just because two lines cross in a circle that lines are congruent. They're very rarely going to be congruent. All you can say is that this angle here is 1/2. Oh, didn't mean to do that. This angle here is 1/2. Ugh. Why is it going from a pen to a... So this angle right here is 1/2 of this arc. But then I have this angle down here, which intercepts the same exact arc. So it is also 1/2 of that arc. Well, if they're intercepting the same arc and they're both 1/2 of that arc, these are congruent. They're 1/2 of the same number. So they'd have to be the same number. So that was one concept you needed to know on the quiz. I'll put some numbers in a minute just to kind of show you what I'm talking about. So again, I could do the same thing on the other side. This, hopefully this works. Yeah, this angle right here intercepts this arc. Well, this other angle right here also intercepts that same arc. So if they are both 1/2 of that arc down there, then those angles would have to be congruent. That was a specific theorem that you could have just memorized. So if you're not getting this, you could have just memorized that theorem. But if you learned the very first theorem about inscribed angles, then you could have figured it out just using the concept that an inscribed angle is half of its intersected arc. So both of those angles are half of these two arcs down here, which means both of those two angles up there are congruent. Let's see. And then the only other thing, not the only other thing, but the main other thing in this particular image is just when two lines cross inside a circle, and when we are talking about arcs and angles, we said that the measure of this angle or the measure of this angle, because they would be the same measure because they're vertical angles, they're across from each other, so they're the same. But the measure of either of those angles, just one of them, is equal to the two arcs added together. So that arc plus that arc divided by 2. So that was when we used this formula. Arc 1 plus arc 2 divided by 2 equals one of the angles. So again, we did that in class. I gave you the sheets. You just needed to look it back over. And a lot of you were getting it when you were working together and doing classwork, but that doesn't mean you can just repeat that on a quiz if you don't look at it again. You don't necessarily retain things forever, as I think we all know. So just because you can do it in class with people helping you and with your notes and with everything in front of you doesn't mean you're just going to be able to do it when I put a quiz in front of you and you have no notes, no help. The notes that you look it over. All right, so let's just do a problem real quick. So if I knew, for example, let's say I'm going to make it pretty tricky. Let's say this is 10 degrees, and let's say this is 12 degrees down here. So I'm talking about this angle here and this angle here when I put those two numbers in. That's the 10 and that's the 12. Whoop. I'm getting it right. All right, so again, it's so hard to do this. Here, I'm going to zoom way, way in and see if I can write it in there again, and then I'll zoom back out. A little better, so 12. That's 12 degrees. All fit that. All right, so we know that's 12. We know the one up above is 10. So what can we say? Well, I know this 10-degree angle intercepts this arc. So immediately, and I know it has a vertex on the circle. So I can say, okay, well, I know it's an inscribed angle of 10 degrees. I know that twice an inscribed angle is the arc. So I can say that is 20 degrees down there. Now I could also notice that this arc right here, I'm sorry, this angle intersects this same arc down here. So I could say if I really wanted to, this arc right here, or I'm sorry, this angle right here is also 10 degrees. That little skinny angle right there. Again, those are both 10 degrees. I know you're probably, some of you are thinking they don't look like it. But again, if you went way back to the beginning of it, where it's really skinny, then you can see that they look more like they're the same angle. All right, so I know that. I could also say up over here, I'm going to go to blue. This angle that's 12 right there, that angle is 12 degrees. Well, it intercepts that arc up there. Right? If I follow that all the way out, it goes all the way up to that arc. So I could say, okay, well, again, the vertex is on the circle, so it's an inscribed arc. And I know if I really studied my stuff, an inscribed angle is half of the arc, or the arc is twice the inscribed angle. So this arc up here, which was probably way more than 12 degrees, but too late now. This arc up here is 24 degrees. So talking about that section right there. All right, so that is 24 degrees. Now, again, if I notice this angle right here also intercepts that same arc, I could, and therefore it's half of that 24. So I could say, all right, well, then that means this angle right here has to also be 12 degrees. What do you really want? Yeah, that's fine. Let's see if I can do that. Oh, no, that did not do it. Why did that do that? Huh. Let me, oh, here, I can at least do this to get rid of a lot of it. I don't know why I erased all that. Actually, I'll just redraw it. That's fine. All right. So this one's 10. I'll just write 10 out here this time. That little skinny angle is 10. This one down here is 12, just like the other one is 12 over there because they intercept the same arc. So I've got a bunch of things that I could do. Now, if I wanted to solve more angles, I have triangles in this. So if I wanted to do something with triangles, I have a triangle here and a triangle with here. So there's two triangles. I know two of the three angles. I know this angle and this angle. So I could figure out the third angle, which I'll show you is right here. I could figure that angle out. I could also do the same thing in this triangle over here. I have 10 there, 12 there. So I could figure that angle out. It'll be the same number because they're vertical angles, so they have to be the same. Plus, I'm subtracting 10 and 12 from 180 in both triangles. So I could figure that angle out. I could figure this angle here out and this angle out, and actually in a couple of ways. But based on what we've been doing, I know the two arcs for those angles. I know there are two lines crossing. We had that whole, let me see if I still have it up. I can easily go to it. Yeah, we had this theorem right here. When two lines cross inside a circle, that was the whole arc 1 plus arc 2 thing. So if I know arc 1 is 24, arc 2 is 20, I could add those together and divide by 2, and I get the measure of that angle is 22 degrees. So I could solve for that angle as well. Again, had I solved for this angle inside the triangle right here, I would have gotten 22 subtracted from 180, so 158 for that angle there. But then I could have subtracted that from 180 because this is a collinear pair. I'm going to get rid of it. So if you need to go back, you can get rid of it. So this pair right here, if I know this angle here, well, this is a semicircle. So I could subtract that one from 180. So again, I could subtract 158 from 180 to get this angle right here, the one that I just told you I solved for a different way using the arcs. So there are a bunch of different ways I could have solved for different things in that figure once I start filling things in. So kind of like that one problem we did both in class and on a quiz where I just said fill in what you know. You could have filled a bunch of stuff in, especially if I gave you some numbers, which I might just do that on one of the retakes coming up, like I told you. This was another problem that we did in class. And again, I feel like a lot of you didn't look it over the night before because it was really just memorizing a formula and plugging numbers in. The problem on the quiz was a little different than the one we did in class, but there were problems like this in your book that you should have done. They were assigned to you. So let's say we know, boy, what would that be? I don't know. We'll say this is 96 degrees. We'll say 100. We'll just make it nice and round. So let's say this arc is 100 degrees. So talking about this arc right there. That's 100 degrees. And then over here, I said, and a lot of people did this wrong. What would that be? I don't know. 34 degrees. So that then I had 34 degrees there. A lot. I don't know. I don't know why people did this. if it's because they thought that was the measure of the arc, but that is the measure of the arc would be somewhere in here if it was written in the picture, not right inside the angle. 34 is the measure of that angle. So with that in mind, I guess I can leave that there. First of all, this formula was not arc 1 plus arc 2. That's when two lines cross inside the circle, and this is not two lines crossing inside the circle. A lot of people use that wrong. It's an incorrect formula. This one is the, where can I put it? Here, I'll just do this. Measure of the angle, which in this case is the 34. So we know that in this case, whoopsies, equals big arc, subtract little arc, divided by 2. And again, a lot of people, if they did get the correct formula, if they use this one instead of the arc 1 plus arc 2, they put the information there for the 34, or in this case, 34. But that's not the little arc. 32, what is it? 34 is not an arc. 34 is the angle. That has to come out here. What am I? 100. So I would say, well, the measure of the angle is 34. Oh, and a lot of people did the algebra wrong too. So I'll show you how to do that. The measure of the big arc is 100. The little arc is what it asked you to solve for. And then 2 goes underneath. A lot of people, well, I shouldn't say a lot, quite a few, they tried to divide by 2 on the right side. You can't divide, well, I mean, you can, but it's not going to get you anywhere because you can't just divide that by 2. You'd have to also divide x by 2. Both of those two things are being divided by 2. You can't really divide by 2 and come up with anything on the right side. You need to get x all by itself by getting rid of things. So again, you could cross multiply. I think that's a pretty good way to do it. So that's the way I'm going to show it. 2 times 34 equals, and it's just 1 times 100 subtract x. So that gives me 100 subtract x equals 64 in this case. Now to solve, I have to subtract 100 and subtract 100. So I get negative x equals negative, what would that be, 36. Well, I don't want negative x, so I need to remember that's actually negative 1. Let's see, fix that. So there's negative 1x. So now I can say, all right, let me divide by negative 1, divide by negative 1. And x is positive 36 degrees. That's the arc. So I just solved for the arc. Now 36 degrees is that. So that was one of the ones that people, and that was the front page was the easy page. So I was a little surprised we didn't do better on that. I'm going to get rid of that stuff and then go back and quickly show you. And this was just memorizing formulas here. There was not a lot of understanding I could give you on this. If I know that this is, oh, let's try to make it realistic. This segment here is 6. And we'll color coordinate. This segment here is 4. And then I know this segment here, now let's do blue. This segment here, let's see, what would that be? If that was 6, probably be like 11-ish. I don't think it's twice that. So we'll say that blue line is 11-ish. If I want to solve for this segment right here, there was a formula. You just had to remember the formula. It was the one that said little segment times little segment from one chord. So we use the 6 and the 4, for example. A lot of people added wrong formula. Again, that just shows me you didn't look it over the night before. There was no addition anywhere in the formula. So it would be, let's do it in, we'll do it in what? Purple. So 6 times 4 equals the two segments, the two smaller segments, the blue and the yellow from the other one, 11. And then for the yellow, I would use a variable because I don't know what the yellow is. That's what I'm solving for. So now we get 24 equals 11x, divide by 11, divide by 11. So whatever that comes out to be, a little over 2 is what x would be, or you could just leave it as 24/11ths is the length of that yellow line. So that was one problem when we were talking about lengths. That's for when two lines cross. So I'll show you what that was for, since there's a lot going on. Here, I'm just going to draw some. So when you have a circle, how do you do that? You have a circle, two lines cross in between, and you want to find the length of one of the segments, one of the shorter segments. You take the segments times each other. So this segment times this segment equals this segment times this segment. You'll typically have 3 of the 4 numbers. So you just put all the numbers in the right place, and then you solve for the x, the missing segment. I think probably. All right, so let's see another problem. Oh, so then you had something like this, but instead of being about arcs and angles, which is what we did before, so instead of big arc subtract little arc divided by 2 equals the angle, it was about the length of the line segments. So if it said, I think it was probably here, let's fix this a little bit. Oh man, why does it keep doing it? I don't remember if it was on the circle or not, but we'll do it. This was the one that, and again, we did these quickly in class. I know that, but I mean, we go fast. Like there's going to be times where you guys have to pick this stuff up on your own. There were plenty of practice problems. So this one, color coordinating, color coding would be big segment. So this entire segment, so not a piece, times this, so times the outer piece, equals, use same colors, the big segment down here times the outer piece down here. So red times green and red times green. So we'll do it with numbers. So if I said, let's see. We'll do it. So if I said this was, what would that be? 3 and 1. That's not big. We'll do 30 and 10. So that's 30 and 10. Boy, I don't even know which one would be shorter, to tell you the truth. Boy. That's longer. I don't know. It's hard to tell. Maybe that's 12. And I don't even know what that's long. We'll say that's slightly shorter. I don't know. Oh wait, no, we'd be solving for that one. So I would solve for that. That would be the x. So again, the 12 is this segment. The 11 is this segment. The 30 is only this segment. And then x is this segment. So that's what those numbers are referring to in this picture. All right. So now the formula was the big segment up top. Well, that's the 30 plus the 11. So the big segment is 30 plus 11. Have to add those together. And then times the little segment outside, the 11. Equals, I didn't know. So that equals, same thing on the bottom. This is where the math gets a little weird though. The big segment down here is this piece right here. All of that. Well, that's x plus 12. Just like we added the 30 and the 11, we've got to add the x plus the 12. And then times the little segment outside, which is the 12. Can I solve here? Let me slide all of this stuff over. Actually, here, let me do this because I'm gonna make it shrink everything down. There we go. All right. Here's where the math got a little tricky, and a lot of people weren't sure how to do the algebra. I multiply or I add 30 plus 11 and then multiply times 11. What's that gonna be? 40, 41 times 11, 410, 421, I think. So all of that on the left over here, I think is 421. You can do it in your calculator and make sure that's right. I'm not gonna pick a calculator up. 41, so that'd be 410. Oh, wait, I'm sorry, that's not right. 450. No, yeah, 450 maybe. Where is that? I think it's 451. If that's still not right, again, just correct it, but same concept. So whatever that is on the left, basically, would go just, I just did the math and just multiply, added, and then multiplied. It's the right part that's the tricky part. Now I could, and this is what a lot of people did, and I think I did it in class, I could distribute the 12 and say 12 times x plus 12 times 12. That would give you 12x plus 144. And then you have a two-step equation. Actually, I'm just going to finish it out like that. Another step is you could divide by 12 on the right. If you're multiplying all of this here times 12, you could just divide by 12 and then divide the left by 12. And then you just have x plus 12 equals some number on the left. If you understand that, great. If not, you can just follow along with what I'm doing here. All right, so I distributed the 12. 12 times x here gave me 12x. 12 times 12 gave me 144. If you're not following this, this is algebra. You've got to learn algebra on your own if you've forgotten some of these algebra concepts. Now I can solve it by getting x all by itself. So I need to get rid of this. Oh, what I do on one side, I got to do on the other side. So now that gives me what? 7 here, 0, 3, I believe, equals 12x. And then I would divide both sides by 12 to get rid of it. And that would be your answer. So x would equal, and I don't even care if you leave it as a fraction, or most of you use calculators, so you give me a decimal, which is fine also. So you'd get that. Whatever that comes out to be, that's the answer. Assuming all the other numbers, right? Let's see. And then I didn't even put, that's the only one I'm going to go over because I didn't even put it, the one with the tangent on it. I'm going to solve for the tangent. I believe that wasn't the entire quiz. Let me just go over one more concept real quick. How can I do this to make it realistic to the quiz? I don't know if it's gonna work or not. So there was a question on there. It's not perfect, but that'll be fine. What do I want to do? So there's an angle. Another line. Just did that. Ah. Ah, I hate this thing. There, that's close enough. How come that? Oh, wait, is that right? All right, close enough. All right, so there's a question similar to this. And I'll just tell you the big assumption people made, which was something we said over and over again you can't do, but I get why you did it. These are all tangent lines. So you guys all said tangent lines, so you thought immediately, oh, they're all tangent lines. I know when I think of tangent lines, I think right angle. So we made some right angles in the picture. Really just one. That is not what the right angle thing means. The right angle occurs with the radius, remember? Or with the diameter if you drew it all the way across. So the right angle is between the tangent line and the radius, not between another tangent line. You can't assume, I mean, none of these are right angles. If that one's a right angle, then you'd have to assume all these are right angles. Clearly, those are not right angles. So you can't just pick and choose which ones are right angles. Um, Again, the only right angle theorem says that between the radius or the diameter and the tangent line is a right angle. So if I drew one to that from this radius, that would be a right angle. If I drew one to that, that would be a right angle. That's the only right angles. So no right angles out here. The concept was we had a bunch of tangent lines, and what we said is if we have a vertex outside the circle and we have two tangent lines, these lines are congruent. That's the concept. And then it was a perimeter problem, so you just had to fill in the pieces and then understand that perimeter is all the sides added up. So you would add these two sides, add these two sides, add these two sides, add these two sides, and then add all of those sides up to get perimeter. If you really want to, you can go back, watch the full video in class for that. But yeah, you cannot assume there are right angles in these corners of tangent lines. All right, so that's it. I think we're going to do some exit tickets to try to um, review that quiz because the grades were very low on that quiz. So you'll probably get some exit tickets. So make sure you practice this stuff a lot because you're going to see it a lot, especially if you're doing a retake.